Hi everybody, my name is Noe. I'm the room host in here. Good afternoon and welcome to BSI Las Vegas. This is Proving Grounds, right? No. Ground Truth. The talk is
Ariana.
Yep, Ariana and predicting the lifespan of internet services, falling down the rabbit hole. And this is given by Ariana Mirian. A few announcements before we begin. Want to thank our sponsors, Diamond sponsors Adobe and Aikido, and our gold sponsors Formal and Run Zero. It's the support along with our other sponsors, donors, and volunteers that make our event possible. The talks are being streamed live, and as a courtesy to our speaker and our audience, we want you to make sure that your cell phones are down and silent. If you have any questions, I'm going to be using this microphone, and you will speak into it so our audience on YouTube can hear you. And and final announcement, data science meetup at 7 p.m. and it's going to be by the pool by the entrance. All right, and with that, I'll leave the floor to you.
Thank you so much. Thanks for being here, everyone. I appreciate it. Okay, this has got to get closer. Hi, everyone. Thanks for coming. I know it's 5 p.m. on Tuesday. We've all got long weeks ahead of us. I appreciate you all being here in person and online. My name is Ariana, and today I'm going to talk about predicting the lifespan of internet services, falling down the ML rabbit hole, and what we learned from the Thud. Just a quick disclaimer, if someone, maybe Christian, could take a photo of me giving the talk at some point when it looks good, that would be great, because everyone is busy, and I need a photo proof of life. Thank you, sir, for that photo. Okay, great. Before I jump into this really long title and what it actually means, I'm just gonna go over a little bit about who am I? Like I said, my name is Ariana. I'm currently working as a senior security researcher at Census. My job is kind of twofold. First, I focus on data quality. So how do we have the absolute best data so that you folks doing security investigations also have the absolute best data? But I also combine the domains of internet measurement and security, or you can think about this as data science and security, to answer interesting research questions about the world and the internet. Before this, I was at the University of California, San Diego. My PhD was unsurprisingly in driving security decisions via internet measurement. I'm also really into birds. So if you like internet measurement, security, or birds, come talk to me. I am really into all three of those things. That's IKEA. They're crazy. Ask me about them later. Great. So I'm super excited to be here today, specifically in Ground Truth, to talk about something really near and dear to my heart. Often when we talk about research, you are hearing about the end result, right? You read a blog, you see a paper, you read about the methods that were successful. Today, I am giving partly a failure talk. So I want to talk about what happened in between the start and the end of our research project. What went wrong, how we reconfigured our solutions, how we reconfigured our thinking in order to get to a correct solution. And also specifically talk about, what happens when you join two subjects that require a lot of domain expertise, cough, cough, security and ML together, and what can go wrong and also what can go right. And so as you probably gleaned, I am approaching this from the perspective of a security researcher, right? Like I have been doing security for 10 years. I'm pretty prolific in networking as well, but this was the first time I was kind of dipping my toes into the ML space with some help of some ML scientist colleagues, so I wasn't doing this alone. But it was a really eye-opening experience. And, we don't often get to talk about the outcomes and the methods. And so I'm super excited to be at Ground Truth to talk about both of those things. And so every time I talk about methodology, I actually put a little light bulb on the top of the slide to just indicate this is a methodology point. And I'll also call it out as much as I can. So today we're going to talk about it all. And specifically, I'm going to just go over a couple points in the next 40 minutes. I'm going to give you a quick background about the internet and why internet-wide scanning matters. Talk about the various iterations of the problem statement and how it changed from problem V1 to problem V2. Talk about the various solutions that we tried. And then finally, what we learned both for the project and for the future. So I'm going to really take you, through us falling down the rabbit hole, which was, trying to find an answer to this project, but also the thud at the end, which was us kind of looking back up at the process and being like, wow, that was kind of painful. What can we learn from that? What can we share with the world about what we learned from that? And that's why the title is so intricate, is because it's been a really good learning experience. So a little bit of background. What is the internet and why does internet-wide scanning matter? I always put the internet in quotes because it is fake. It should not. It is just a strange entity that rules a large portion of my and others' lives. But jokes aside, the internet is a very fraught and dangerous place. There's a lot of bad actors out there. And just to make sure we're all on the same page, when I say the internet, I think of the collection of hosts that make up this networking entity, right? And when I say a host, I think of servers or network devices that are typically comprised of an IP, port, protocol, and autonomous system. And for those that aren't super familiar with networking, autonomous system is like the routing policy of the specific device. So like who controls how it gets routed to the rest of the internet. The hosts can tell us really interesting information about themselves. Not only are the port and protocol that they are using to speak with the rest of the internet inherently interesting, but we can also collect other interesting metadata, like what vulnerabilities are they purporting, what software or hardware version are they, and internet-wide scanning is a way that we can get all of that data in one place. And so if you look at this graphic on the left, right, we have our set of devices, and then a shop like Census, which is where I currently work, will go out and scan all of these devices to collect as much public data about those devices as possible, again, to enable research about various vulnerabilities, various devices, software, hardware products, etc. And the caveat here is that the more accurate your data is, the more accurate your insights are going to be, right? If you have scan data that is a week or a month old, your insights into that data are going to be a week or a month old. But if you have really, really accurate data that is super up to date, your insights will also be conversely up to date. And one thing that I have realized in my tenure with internet-wide scanning is that many hosts are ephemeral. So if you imagine like a faulty Christmas light that's blinking in and out, there's a lot of hosts on the internet that we scan them and they are responsive and they're like, hey, here's who I am and here's what I talk and here's all the vulnerabilities I have. And then we scan them a couple hours later and they are just gone, or they appear to be gone. And then like 4 hours later, they're back again. And I'm like, come on, just make up your mind. This would make my life a lot easier. These really ephemeral hosts complicate this accurate picture that we are trying to depict. And so the first version of the problem is that we want an accurate representation of the internet at any given point, but we have these highly ephemeral hosts that make up a minority of the internet that are kind of mucking up the data. And so we're like, well, okay, what do we do about this? Well, I'm a scientist by training, so I'm like, let's go run an experiment. And so we set out to quantify the ephemerality of the internet. And so in doing so, we scanned a representative set of services every hour for a week. And if you're like, hey, Ariana, this is sounding really familiar, that's because this is the talk I gave last year in Ground Truth at B-Sides Las Vegas, where we scanned the internet every hour and showed a bunch of, interesting graphs and behaviors and examined the internet at these different service level attributes. So again, port, protocol, autonomous system. And I'm not going to go over that talk again, but the biggest takeaway from that descriptive analysis and from the talk about a year ago is that the internet is highly ephemeral. It's a minority of services, and also the internet is not uniform in its ephemerality. While we might find that like a portion of hosts that are over port 443 are super ephemeral, that can vary widely depending on the autonomous system, that can vary widely depending on the protocol you're looking at. And so we were doing all this descriptive analyses to try and glean, insights into the ephemerality of the internet. And the biggest thing we could take away is like, wow, this is a mess. This is really noisy. And so, I presented this work. We continued to do some of the research. And then at some point we were like, Man, the outcomes are not clear. We are having a difficult time figuring out the takeaways for us to use internally, for us to go publicize. And so at this point, this is the little methodology light bulb. We're here. This is, failure step number one, is taking a step back, right? It's like, okay, the data is messy. We're having a hard time with, simple descriptive analyses, trying to figure out what are the takeaways and outcomes for us. And so we took a step back and said, what are our end goals with this data set, with this project? And, we came up with two very specific end goals. One is to come up with a method that allows us to identify which services should be scanned at a faster rate that takes into account this noisiness, right? If one autonomous system has mail servers that should be scanned at a faster rate, I don't want to scan all the mail servers at a faster rate. I don't want to scan that entire autonomous system at a faster rate. It is a specific subportion of a subpopulation of the internet. So we wanted a method that would more easily help us identify these different small portions of the internet that we should be scanning faster. We also wanted an understanding of what affects internet service lifespans. In other words, we wanted to not deduce, we wanted to figure out the feature importance of what causes a service to be ephemeral. Is it just its port? Is it its protocol? Is it a combination of those three? And this feature importance is more of an underlying understanding of the behavior of these ephemeral hosts, but it allows us as an internet-wide scanning entity to go and then figure out, okay, does this change our internal scanning policies? Do we alter the way we think about ephemerality and how we scan internet services based on the model's outcome? So we came up with these, we took a step back, made sure we were all on the same page with our end goals, and we're like, okay, well, let's reframe the problem, because the original problem was just like, we want an accurate picture of the internet is great. That's like our guiding light, but that's not actually helping us solve the data problem. And so the problem then evolved into, how can we predict the lifespan of ephemeral services? And then it was at this point that ML entered the room. It is so hot right now. It just felt very timely given all the conversations of ML. And I should say that, I was very hesitant to dip my feet into the domain that is machine learning because, right, like I said, I am a security expert. I am a networking person. And I was like, trying to figure out how to marry two different domains is going to be a challenge and a journey in and of itself. And that is why we're here, because it was, in fact, a journey. So many of you may be asking, okay, but why prediction? Why didn't you reframe, your V2 of the question to be something different? Prediction allows us to have smarter and more accurate scanning. So if we can predict, so just to really concretize this, if we can say host A is going to change its state in 8 hours, host B is going to change its state in 12 hours, so those need to go into different scanning buckets that are scanned at different rates. Again, that helps us get more accurate data. So this is where prediction is really useful. But also, and my background is also more in statistics. I actually tried a lot of statistical models, and that is just a completely different talk for another day. That's like a whole other 45 minutes. The issue with a lot of the statistical models is that they had really strict assumptions that internet-wide scanning data breaks. And while they showed relationships between variables, it was much harder to glean that feature importance, which was, the what are the service level attributes that help predict ephemerality. And then at the end of the day, we wanted both prediction and feature importance, right? I didn't want to be running a ton of different models and then trying to pull it all together. Spoiler, I did actually try that. It really didn't work well. And so we're like, okay, let's dip our toes into the ML space, because it seems like there are some machine learning models that can help us get both prediction and relational information, which are going to solve both of our end goals. And so this is an explanation for why we wanted to use prediction. And then the next step was like, okay, great. Well, which model are we going to use? Because there's a lot, right? It's not just like, ML, throw it in. It's like, this is an entire field where people have spent years training and understanding these models and what's going on under the hood, much like me and my colleagues have spent years understanding the internet and security and whatnot. And so, again, we're like, okay, well, what do we have? What do we have and what are we trying to get? Our input features for each service, for each host, we have port, protocol, autonomous system, which again is like the routing policy. we'll just leave it at that for lack of time, and whether the scan was successful or not. And so you can imagine that like we have, and this picture shows, if we have the host, we have its port protocol, and also like kind of where it's getting routed or who it's getting routed by. And then also like, was it responsive or not? Because we were doing these hourly scans. So there were times where hosts just went away, and I was like, well, we'll check again in an hour and see if they're back. Given these, we wanted to predict the lifespan of a service. Again, is it going to change state in 1 hour? Is it going to change state in 6, 12, 24, in a week? I want to know. I want to know about all the services. And so we were looking at the inputs and we're like, okay, well, lifespan of services is a numerical output that's in hour chunks. And so looking at all the different model families and also, again, consulting with the ML scientists that we have in-house, I was like, okay, well, let's try regression, right? Regression handles numerical output. And bonus, they don't always assume linear relationships because there's no way that there are linear relationships in internet-wide scanning data. And so solution V1, let's use a regression. Seems super simple. My life is going to be great, and we're going to have all the answers to the problem. No, that is not what happened. We actually ran into a lot of issues with trying to use regression for this problem. And this is where I'm going to walk through again the difficulties, like the failure cases of what exactly was going wrong, because we wanted to understand why this was failing so spectacularly to figure out, is there a potential solution, or do we just like abandon ship and move on to the next, problem in the internet-wide scanning space? And so the first big issue was with our input variables. So we had port, protocol, autonomous system. They're categorical. Lots of models require numerical input. Even if they take in categorical input, they're still like converting it into numerical under the hood. But that's okay because we have a way to handle this. There is so you can essentially encode these variables, right? And there's a popular technique called one-hot encoding. This was one of the many that we tried. But just to walk you through it, on the left-hand side was the original data set. So each row is a specific host and what port it had open and what port we were scanning it on. And so when you one-hot encode, you're essentially taking each of the possible variables, converting them into their own column, their own variable name, and then listing the true and false variables. And so if we convert the left-hand side into the right-hand side, we'll see that port 80 and port 443 are now their own columns. And port 80, since the first row had port 80 open, there is a 1 for the first row for port 80, a 0 for port 443, and then the converse for the second row. This is a super straightforward technique. There's other ways to encode things, but this is just, the one that is most easy for me to graphically explain in the time that I have. Seems like this should work, right? Nope. The issue is that a lot of our variables had really high cardinality. They had a lot of potential categories they could be in. And just to put some numbers behind this, we had 40 potential ports, 300 potential protocols, and 19,000 potential autonomous systems. And so imagine that each of those is becoming a column. Your matrix all of a sudden is so sparse, the model, spoiler, can't do much with it. And on the right-hand side, I just have an example of, for those who are unfamiliar with autonomous systems, some example of autonomous systems. So you can have universities, financial institutions, these are large organizations that own IP space, and then route that IP space. And so this is where, we have some great ML scientists in-house, and we were chatting constantly about this. And this is when one of our ML scientists was like, well, Ariana, just get rid of autonomous system. That's such a problem feature. You don't need that. And this is where having domain expertise in both domains is so helpful, because me as the networking security person was like, wait, autonomous system is so critical to the underlying nature of a host. We can't just throw it out. And again, my ML scientist colleague, fantastic person, did not have the networking background. So they were just like, oh yeah, we'll just get rid of it. And I was like, no, we're not getting rid of that. No, we cannot. And so we reached a compromise where we're like, okay, let's reduce the cardinality. Instead of 19,000 potential autonomous system options, what if we boil down the autonomous system feature into its category? So, we say this is a educational autonomous system, a financial autonomous system. That dropped that feature down to about 200 options, and it was still a super sparse matrix with like slightly less abysmal results. And so even with this compromise, we weren't getting great outcome. And just to put some numbers behind what I mean by not great outcome, when you run a regression, one of the key metrics of success is your R squared. And so R squared is essentially how well the model is explaining the variance in the data. It is on a scale of 0 to 1. And the best thing I could get was about 0.3. Most of the time it was below 0.2. And so that means that the model was taking the data in and only able to describe at best 30% of the variance in the model based on the features that we were putting into it. In the words of Gordon Ramsay, that was just not good enough. And you know, this is where the practicality of industry kind of butts head with the science of academia and these mathematical models, because in a lot of cases, you know, an R squared of 0.3 actually is quite sufficient. But one of the other difficulties is that we were trying a lot of different regression models to see if they would at least have the same output, right? So again, the feature importance was a secondary goal for us. And these models were outputting feature importance that was all over the place. I mean, like, one would say autonomous system was important, one would say port was important, one would say protocol was important. And again, in consulting with my ML domain expertise colleagues, our understanding is that the models just weren't really grasping what was happening underneath. They were not converging in a way that made sense to any of us. And we also couldn't explain it, right? Imagine going into a meeting with a bunch of your other colleagues who are expecting you to come with outcomes, and you're like, so one model said this, and the other one said this, and the third said this, and yeah, like, what do you take from that? Not great. The light at the end of the tunnel, the slightly depressing thing is that this is obviously not a unique problem to us. I started looking at published research, actually in other domains, like human-computer interaction has a lot of really peer-reviewed published work where the authors were like, yeah, we have this high cardinal data set, and we tried a regression and it was not great. And so we moved on, and I was like, okay, that's encouraging because maybe there is a solution here. Yeah, and I was like, a lot of research was using high cardinal data that had the exact same results, and the results were abysmal. It was really discouraging. And so we were like, okay, let's take another step back. Our light bulb is back. How can we reclassify the research question to then use a model that actually works with the data, that is something that we can act on, that we can explain to like the data engineers, that we can explain to people who are like, okay, so why do you think we should change our scanning in the way that you're proposing? And when we were poking around at some of the data, we realized, we revisited this facet of the data set, which is that the output variable had incredibly bimodal output. So remember, our output is the lifespan of a host. So that can be anywhere from an hour to a week, because that's how long we ran our experimental data set. And when we plotted the distribution of lifespans, it is a heavy concentration on the left side. So again, the small minority of hosts that are pretty ephemeral, and then a huge chunk that are just online. They are homies, they are online, they are just consistently responding positively. And so we were looking at this and we're like, okay, well, can we use this to our advantage, right? And I'm gonna revisit our end goals because we wanted a method to identify which services should be scanned at a faster rate, which really meant these services should be scanned in X hours, these should be scanned in Y, etc. What if we just reframed it and made our lives easier and say, hey, these are the less ephemeral hosts and these are the more ephemeral hosts. So taking this bucket, these two obvious buckets, and instead treating our problem like a bucketing problem instead of a regression or a very exact precision prediction problem. And so that led us to solution V2, which is, hey, let's use a classification. Again, this may not be the most academically rigorous thing. If I try to submit this to a research conference, I'm sure they would be like, wait, but like regression is the thing that you should definitely use for this problem. But practically, for us, if we want more accurate data, and we're scanning most hosts at roughly a daily cadence, even if we can say, okay, this set of hosts should be scanned in a 12-hour cadence or a 6-hour cadence, and then everything else remains the same, that is still an improvement for us. That is still improving our accuracy. And again, this is kind of the joys of being able to work in a more practical industry setting where I don't need to worry about the woes of reviewer 2. I can be like, what is the thing that is practical? I know I'm seeing some people laugh. What is the thing that's practically going to help us? A classification will practically get us to an answer to our problem. Classification went great. It was fantastic. I was like, thank God I can do my job, because there were some dark moments in this. So we divided our output into highly ephemeral hosts, so hosts that had a lifespan of less than 12 hours, and less or low ephemeral hosts, which is everything that was 12 hours plus, right? And again, that's because our scanning cadence is roughly daily. There's some nuance there. And so if we can even say, hey, this 10% we should be scanning at a 12-hour rate, again, that is still going to increase our accuracy and get us closer to the goalpost of having the most accurate representation of the internet. We also stumbled on this model called CatBoost, which natively handles categorical data. Again, it is still converting it into numerical inputs. But what was really solidifying about this decision is that we tried CatBoost, we tried random forest trees, we tried a couple different classifiers. And though they were performing at slightly different accuracies and slightly different ROCs, the feature importance was always the same. They were converging on what they thought were the features that most predicted ephemerality. This was not happening with regressions, LOL sob. And so I was like, okay, there's some slight differences, but they're all mostly behaving the same way, which is what we would expect in a well-defined research problem with a well-defined data set. We also didn't really need to reduce the cardinality of the data either. I just threw in all the autonomous systems. I didn't need to do any of this categorical stuff. That's really helpful for us because now I can be like, these autonomous systems, these hosts in these autonomous systems need to be scanned faster or not as quickly, and the results weren't abysmal. And so when I say they weren't abysmal, we were able to get an accuracy of 87% and an ROC AUC of 94%, which is like a night and day difference from what we were seeing with the regression. We also got a feature importance that was successfully ranked and reproducible against different models. And this is really interesting to me. So autonomous system is the highest ranked feature when we are talking about the lifespan or the ephemerality of a service. And that is super interesting to me. And now we are having a lot of internal discussions and ongoing research about how that changes some of our base assumptions about how we've been scanning the internet. To then get more accurate data. There were also some other features that were important, like number of services on a host, the port, the protocol, but it was really autonomous system that stood out above the rest. And we had some really good precision and recall. So overall, this was a great success compared to the results that we were dealing with before. And then we were like, hey, that worked really well. What if we modified our classification buckets slightly and actually expanded this into a 3 classification problem. So now it's like we scan certain hosts at 12 hours, we scan certain hosts at 24, and then everything else we can scan it at more than a 24-hour cadence, which I think practically we'll still probably scan at 24. But this was like a nice little, let's expand this and see if this continues to work, right? In the words of Moto Moto from Madagascar 2, so nice, you gotta say it twice. Anyone? No? Great movie. Highly recommend. Thank you. Again, our accuracy and ROC were like really well. I was like running these, and these are with hyperparameter tuning and whatnot. I don't have the parameters up here because it didn't seem as relevant for this discussion. But I would like run the base model with just some really basic input parameters, and like the accuracy would come out at like 75%. And I was like, am I dreaming or does this work? In this 3 classification problem, again, we also investigate our feature importance. The autonomous system was still highest by far, but then port and number of services flipped. And so that's something that we're investigating. Why that is, what does that mean for us? And and if the 2 classification or 3 classification is more suited for our needs. And so some interesting open questions, you know, as with all sorts of research, there is always more to dig into, but this was still a great success. So at this point, so this was, you know, kind of the evolution of the research project. We're taking a lot of this, we're digging in further. I'm pretty sure I won't be giving a follow-up talk on this next year, but who knows? Never say never. And so at this point, I kind of want to take a step back and talk about the 2 different sets of lessons we learned. So lessons we learned from falling down the rabbit hole, or the project-specific lessons, right? Using network-level features, we were able to train a classifier with high accuracy and predict service-level ephemerality with reproducible features. Autonomous system is the feature of highest importance, which, like I said, helps us understand how we should address internet ephemerality better. It also is helping us, again, with some of these internal conversations that are ongoing. Maybe that'll be the 3rd version of this talk, is like how we change internet-wide scanning. Probably not. The one thing I really want to point out is, no, I think that's on the next slide. I got too excited. So it was like, great. This is a really helpful project for us internally. We got our findings. Let's move forward with it and make our accuracy better. Let's make our data quality better. But what were the lessons that we learned from the Thud, right? This was a very long process. I distilled it into roughly 35 minutes, but this was not a 35-minute task, and took a lot of domain experts coming together. You know, first off, domain expertise in both areas is super critical. If I had been tackling this on my own, or if my ML colleagues had been tackling this on their own, I think it would have taken more time. We would have it may not have been successful, and we may have come to different outcomes. And so being able to have both people in the room was super, super useful. And so I would highly encourage, if you are ever dipping your toes into a different domain, find someone who works in that domain. It's also fun, you know, working with good people, doing good research. I had a great time, even though there were some days where I was like banging my head against the metaphorical wall. Rethinking your analysis is necessary even in the ML domain. And I've kind of touched on this before, but one of the biggest things for us was saying, hey, how do we address the practical issue outside of the scientific one? Like, yes, I would love to get a research paper out of this, but the reality is we're not doing anything novel with the ML models. Really what we need is a practical understanding of what dictates internet service ephemerality, such that it helps us internally with some policy decisions. And so that means that we converted a regression to a classification because of various factors. And that gave us really good performance, which practically and scientifically is helpful for us. And so really being able to take a step back, rethink what is important, what isn't important, what can you leave on the table, and what do you need to take with you, was really critical here. And I will say this process has been, it was not foreign to me. In my 10 years of doing research, there are so many times where we have needed to take a step back, rethink the problem. What are we doing? What are the analyses? And this was just the most recent case of that journey. Internet level data is super noisy, surprise. And network level features perform much better in these models than software level features. So one thing that I didn't include a slide on is that we were trying different features. So we had the network level features because that is inherent to the internet-wide scan, but then we can also add some software level features like what product is this? What vendor is this? What version is this? And we tried to include some of these other features. And even though the model was still performing well in terms of accuracy and ROC, those software level features were like at the bottom of the feature importance list. I mean, they were just so obviously not important to the model output. And this is really important to us because I'm like, great, so now moving forward, we'll focus on network level features. And that doesn't mean I've like sworn off on software level features, but this is very useful for us in other endeavors that are going on internally. Science be sciencing. That's been great. With that, I want to thank you folks for your time, and I would be remiss if I didn't thank all the fantastic folks I work with at Census. Good research is not done in a vacuum, and I have some really good people doing some great work at Census, and I'm really thankful for them. With that, I'm happy to open the floor to questions, and thank you folks for your time.
Hey, thanks. Great talk. I'm curious. So you looked at the autonomous systems having a substantial impact on the model.
Yeah.
Did you then go back and look at those autonomous systems as to what the autonomous systems that were very ephemeral were specifically?
Yes, I did. Yes, I did. I'm not sure how much we wanna share some of that information.
Great talk. Question about when you have that binary output of scan successful or not.
Yeah.
So so I mean, that could be a failure of the host to respond. It could also be a failure of the scan itself. What quality processes do you have in place when you have a previously successful scan and then an unsuccessful scan in validating that your own scan was successful on your side?
Yeah. Great question. So before we launched this experiment, we did a bunch of quality testing so we basically ran our scanner against hosts that we knew were definitely up. And so we tested across different ports, protocols at different speeds to try and find that optimal place of how quickly can we run our scanner while still getting 100% success rate, again, based on our ground truth data set. So we basically tuned our own parameters of the scanning to feel confident in the quality. We also did this, what's the word I'm looking for? We further cleaned the data set where we said, okay, if we see a host that is successful, because we had hourly scans, and then for an hour it blips away, but then subsequently is back, we're actually going to count that as a false negative. So that was us cleaning the data based on our knowledge of the internet. I will say that those false negatives were few and far in between, but that was another thing that we were like, listen, based on our understanding of the scanner, based on our understanding of the internet, things most likely aren't disappearing for just an hour. And so because we had that high granularity data set, we could essentially patch it, which was a cleaning mechanism. Yeah.
Sorry, just a follow-up question to that. Have you considered for hosts that are,
Sorry, can you repeat that question?
sorry about this, just a follow-up question.
No,
so have
please.
you considered for hosts that are traditionally very not ephemeral, very, well-established, have a very low downtime, that when you do have one of these like one-offs, that you initiate a secondary scan at like a slower frequency to immediately afterwards? Have you considered other things like that, and do you guys deploy that? Just out of curiosity.
Yeah. So for the experimental data collection, we did not do that specifically because of time. And so this was some of the details I talked about last year, but because we deployed these hourly scans, we were very limited in the sample of hosts that we could scan because we can only scan so much in a given hour with the hardware that we have. And so we didn't do retries for the experiment, but that is something that we do at the production level. So there are other checks at the production level. So when you're in census, that data is the highest quality possible. But that's why for our experimental data set where we ran 1 hour scans, we did that patching mechanism to account for we didn't want to do the retry because then the retry means instead of scanning 4 million hosts, we could probably only have scanned 3 based on bandwidth load. And so it was experimental design. Great question.
Anyone else? All right. Thank you, Ariana.
Thanks, folks.